Graph f of x equals the quantity x minus 1 times the quantity x plus 3. Describe the domain and range. Begin by identifying the x-intercepts. Notice that f is of the form f of x equals a times the quantity x minus p times the quantity x minus q. Rewrite the function to identify p and q. Here p is 1 and q is negative 3. So the x-intercepts are p equals 1 and q equals negative 3. So plot the points negative 3, 0 and 1, 0. Now you want to find and graph the axis of symmetry. The axis of symmetry is x equals the quantity p plus q divided by 2. Substituting 1 for p and negative 3 for q, you get the quantity 1 plus negative 3 divided by 2. 1 plus negative 3 is negative 2, and negative 2 divided by 2 is negative 1. So graph the axis of symmetry along the line y equals negative 1. Next, find and plot the vertex. The x-coordinate of the vertex is negative 1. To find the y-coordinate of the vertex, substitute negative 1 for x in f of x and simplify. F of negative 1 equals the quantity negative 1 minus 1 times the quantity negative 1 plus 3, which simplifies to negative 4. So the vertex is negative 1, negative 4. Now draw a parabola through the vertex and the points where the x-intercepts occur. Next, you want to find the domain and range. The domain is the set of all possible x values. From the graph, you can see that the domain is the set of all real numbers. The range is the set of all possible f of x values. From the graph, you can see that the range is the set of all real numbers greater than or equal to negative 4, which can be represented by the inequality y is greater than or equal to negative 4. Graph f of x equals 3x squared minus 3. Describe the domain and range. Begin by rewriting the quadratic function in intercept form. F of x equals a times the quantity x minus p times the quantity x minus q. To do this, first write the function. 3x squared and 3 have a greatest common factor of 3, so factor a 3 out of each term. X squared minus 1 is a difference of 2 squares, and can be factored as x plus 1 times x minus 1. The quantity x plus 1 can be written as the quantity x minus negative 1. The function is now in intercept form, where p equals negative 1 and q equals 1. So the x-intercepts are p equals negative 1 and q equals 1. So plot the points negative 1, 0 and 1, 0. Now you want to find and graph the axis of symmetry. The axis of symmetry is x equals the quantity p plus q divided by 2. Substituting negative 1 for p and 1 for q, you get the quantity negative 1 plus 1 divided by 2, which simplifies to 0. Now you want to find and plot the vertex. The x-coordinate of the vertex is 0. To find the y-coordinate of the vertex, substitute 0 for x in f of x and simplify. f of 0 equals 3 times 0 squared minus 3, which simplifies to negative 3. So the vertex is 0, negative 3. Now draw a parabola through the vertex and the points where the x-intercepts occur. Next, you want to find the domain and range. The domain is the set of all possible x values. From the graph, you can see that the domain is the set of all real numbers. The range is the set of all possible f of x values. From the graph, you can see that the range is the set of all real numbers greater than or equal to negative 3, which can be represented by the inequality y is greater than or equal to negative 3. Find the zeros of f of x equals the quantity x minus 5 times the quantity x plus 7. To find the zeros, determine the x values for which f of x equals 0. To do this, substitute 0 for f of x. By the zero product property, you can set each factor equal to 0. So you have x minus 5 equals 0 or x plus 7 equals 0. To solve x minus 5 equals 0, add 5 to each side, giving you x equals 5. To solve x plus 7 equals 0, subtract 7 from each side, leaving you with x equals negative 7. So the zeros of the function are 5 and negative 7. Find the zeros of each function. Part A. F of x equals 2x squared minus 8x minus 24. Begin by writing the function in intercept form. 2x squared, 8x, and 24 have a greatest common factor of 2, so begin by factoring a 2 out of each term. X squared minus 4x minus 12 factors as the quantity x plus 2 times the quantity x minus 6. For any factor x minus n of a polynomial, n is a zero of the function defined by the polynomial. You can rewrite x plus 2 as x minus negative 2, which is of the form x minus n, where n equals negative 2. X minus 6 is of the form x minus n, where n is 6. So the zeros of the function are negative 2 and 6. Part B. H of x equals the quantity x minus 2 times the quantity x squared minus 25. Again, you want to begin by writing the function in intercept form. X squared minus 25 is the difference of two squares and factors as the quantity x plus 5 times the quantity x minus 5. X minus 2 is of the form x minus n, where n equals 2. X plus 5 can be written as x minus negative 5, which is of the form x minus n, where n equals -5. And x minus 5 is of the form x minus n, where n equals 5. So the zeros of the function are -5, 2, and 5. Use zeros to graph h of x equals x squared plus 3x minus 4. The function is in standard form, where a equals 1 and c equals -4. Because a equals 1 and 1 is greater than 0, you know that the parabola opens up. And because c equals -4, you know that the y-intercept is -4. So begin by plotting 0, -4. Notice that the polynomial that defines the function is factorable. So write the function in intercept form and identify the zeros. X squared plus 3x minus 4 factors as the quantity x plus 4 times the quantity x minus 1. For any polynomial factor x minus n, n is a zero of the function defined by the polynomial. X plus 4 can be written as x minus -4, which is of the form x minus n, where n equals -4. And x minus 1 is of the form x minus n, where n equals 1. So the zeros of the function are -4 and 1. So plot the points -4, 0, and 1, 0. Then draw a parabola through the points. Write a quadratic function in standard form whose graph satisfies the given condition or conditions. Part A. X-intercepts -1 and 5. Because you know the x-intercepts, use intercept form to write a function. Intercept form is f of x equals a times the quantity x minus p times the quantity x minus q. You are told that the x-intercepts are -1 and 5, so substitute -1 for p and 5 for q. X minus -1 can be written as x plus 1. So you have f of x equals a times the quantity x plus 1 times the quantity x minus 5. Many possible functions satisfy the given conditions. The value a can be any non-zero number. To allow easier calculations, let a equal 1. So you have f of x equals the quantity x plus 1 times the quantity x minus 5. The quantity x plus 1 times the quantity x minus 5 is x squared minus 4x minus 5. So a quadratic function is f of x equals x squared minus 4x minus 5. Part B. Vertex -3, -2. Because you know the vertex, use the vertex form to write an equation. The vertex form is f of x equals a times the quantity x minus h squared plus k. You are told that the vertex hk is -3, -2, so substitute -3 for h and -2 for k. X minus -3 can be written as x plus 3, and adding -2 is the same as subtracting 2. So you have f of x equals a times the quantity x plus 3 squared minus 2. Many possible functions satisfy the given condition. The value of a can be any non-zero number. To allow easier calculations, let a equal 1. So you have f of x equals the quantity x plus 3 squared minus 2. The quantity x plus 3 squared is x squared plus 6x plus 9, and 9 minus 2 is 7. So a quadratic function is f of x equals x squared plus 6x plus 7. Use zeros to graph f of x equals -x cubed plus 4x squared minus 3x. Notice that the polynomial that defines the function is factorable, so write the function in intercept form and identify the zeros. -x cubed, 4x squared, and -3x have a common factor of -x. So factor -x out of each term. X squared minus 4x plus 3 factors as the quantity x minus 3 times the quantity x minus 1. Because f has a factor of x, you know that one of the zeros is 0. For any polynomial factor x minus n is a zero of the function defined by the polynomial. X minus 3 is of the form x minus n, where n equals 3, and x minus 1 is of the form x minus n, where n equals 1. So the zeros of the function are 0, 1, and 3. So plot the points 0, 0, 1, 0, and 3, 0. To help determine the shape of the graph, find points between the zeros. Substituting 1/2 for x in f of x, you find when x equals 1/2, f of x equals -5/8. Similarly, when x equals 2, f of x equals 2. So you also want to plot the points 1/2 -5/8 and 2, 2. Then draw a smooth curve through the points. The graph The graph represents a cubic function. Write the function. From the graph, you can see that the x-intercepts are -3, 0, and 3, so use intercept form to write a function. Intercept form is f of x equals a times the quantity x minus p times the quantity x minus q times the quantity x minus r. Substitute -3 for p, 0 for q, and 3 for r. X minus -3 can be written as x plus 3, and x minus 0 is x. So you have f of x equals ax times the quantity x plus 3 times the quantity x minus 3. Use the other given point, -1, 2, to find the value of a by substituting -1 for x and 2 for f of x. -1 plus 3 is 2, and -1 minus 3 is -4. -1 times 2 times -4 is 8. So you have 2 equals a times 8. To solve for a, divide each side by 8, leaving you with 1/4 equals a. So you have f of x equals 1/4 x times the quantity x plus 3 times the quantity x minus 3. The quantity x plus 3 times the quantity x minus 3 is x squared minus 9, and 1/4 x times the quantity x squared minus 9 is 1/4 x cubed minus 9/4 x. So the function represented by the graph is f of x equals 1/4 x cubed minus 9/4 x.